All right, this is the podcast for the counting atoms and balancing chemical equations test. So to start out with, we need to grab a pen here, maybe a little red pen. Okay, so I'm going to count the number of atoms in this formula. It might be smart to separate out the different elements here so you can see them clearly. I've got a nitrogen, a hydrogen, and a chlorine. The little 4 here means 4 nitrogens. I have 4 hydrogens. I have 1 nitrogen and 1 chlorine. So if you just add up the little subscripts, you'll notice you get a total of 6. All right, well that's one of the easy ones. Now this one here is a little harder because I can separate out the nitrogens and the hydrogens. We have 1 of those and 4 of those. So that's a total of 5 atoms inside the little parentheses. Now this little 2 here, just to the right of the parentheses, means that everything inside that parentheses is times 2. So you have to understand what the meaning of that is. And then on the other side of the parentheses in the 2, there are these atoms, and you basically add these on to everything else you calculated. Notice there's 1 of them there and 4 there, so a total of 5 more. So here we have 4 plus 1, 5 inside the parentheses, times 2 is 10, plus 5, the answer is 15. Okay, number 3. Now this is exactly the same formula as we just saw, and if you recall, this has 15 atoms in it. Now the 2 out front here, and for that matter the 3 out front here, this is called the coefficient. And what it does is it takes everything behind it, all the atoms, the parentheses, everything, and it doubles it. So simply takes the 15 and times 2, so the answer here is 30 atoms. So now we have to look at this whole formula first, and then we have to leave this 3 on the outside till last. We're going to multiply everything inside the formula by 3. Okay, starting with the parentheses, we have OH, so that's 2 atoms, 1 oxygen and 1 hydrogen, times 3 for a total of 6 atoms. And then you have to bring down this atom here, 1 atom of aluminum, plus 6 makes for a total of 7 atoms. But then now we have to multiply that by the 3 here. 7 times 3 is 21. So this first part of the test is, can you add atoms in a formula? Okay, balancing chemical equations. I encourage you to make a line through the arrow, and over here put all of the elements down that are on the left. There is only 1 sodium, and there is 2 iodines. Over here we also have to have sodium and iodine. And we have 1 and we have 1. Okay, so obviously we have 2 iodines and 1 iodine. We need to double the amount of iodine here on the right. So if I multiply by 2 and that doubles the iodine, this number here I used to multiply with has to go out front. But now that means it's 2 times everything in the formula behind, so I have to end up multiplying the sodium also by 2. So now we have 2 and 2. Over here on this side we have 1 and 2, so clearly I have to multiply this by 2 to bring these numbers up to the same as this. So to put a 2 there, I only needed 1 of these and a 2. That's the balanced chemical reaction, was a 2, 1, 2. So here we have to list all the atoms on this side. 1 potassium, 1 chlorine, and 3 oxygens, as you can see. Over here I have 1 potassium, 1 chlorine, and 2 oxygens. So we have 3 oxygens and 2 oxygens. So what I want to do is I want to take and multiply these 2 oxygens by 3. That gives me a total of 6 oxygens on this side, and multiply these oxygens by 2. 3 plus 2 times 2 is also 6. So notice that improves the oxygens. So the number I use to multiply with goes out front. and now in this case times 3. So I have to put the 3 here. All the oxygen is right here. All right, that's good. So at this point we have one of those and one of those. This doubled the amount of potassium and doubled the amount of chlorine. So what I need is to double these by putting a 2 here. And you see that doubles both of these. So now I have 226 and then 226. Okay, now in this equation, I noticed I have a PO4 here. This is a phosphate molecule. It's an ion, actually. It's a -3 ion. Well, over here on this side, I have the same exact phosphate ion, 3-. So I'm going to just say that these oxygens are identical to these oxygens, and that kind of functions as a trick. So I have hydrogen here and chlorine. I have potassium here. So notice on this side of the arrow I have potassium, phosphate, hydrogen, and chlorine. Here I have phosphorus and chlorine, hydrogen, and phosphate. Okay, so then here I have 3 phosphoruses, and I'm going to take the entire phosphate and balance the whole thing. I have only 1 hydrogen and I have only 1 chlorine. Over here I have 1 potassium. Okay, so I have my phosphate. I have 1 also on this side. I have actually 3 hydrogens on this side, 3 H3, and I have 1 chlorine. Okay, so I've got to fix these hydrogens. I'll go ahead and start by putting a 3 here. That triples the amount of hydrogens and triples the amount of chlorines. So that fixes the hydrogen. Now the chlorines are off, so maybe the best bet is to triple the amount of chlorines here. That also triples the amount of potassium here. Okay, so then everything is good. 3, 1, 3, 3, 3, 1, 3, 3. And so it's going to be a 1, 3, 3, 1. Now this combustion reaction with a fuel reacting with oxygen to make carbon dioxide and water. So I have carbon, hydrogen, and oxygen on both sides. Let's go ahead and lay that out. 3 carbons, 8 hydrogens, and only 2 oxygens. On this side I have 1 carbon, I have 2 hydrogens, and I have 3 oxygens. 1 and 2 totals up to 3. I like to leave the oxygens till the very last. Okay, just do that on these type of equations. Start with the carbon. All right, so I need to put a 3 here to make the carbons the same. That changes my oxygens to 3 times 2 is 6, plus 1 is 7. Okay, now that we just fixed the carbons, let's fix the hydrogens. 8 on this side and 2 on this side means I should multiply this by 4, and that changes this to 8. 4 times 2. All right, that's good. Now that also changed the oxygens on this side. Here is 6 and 4 is 10. Okay, so I still have 1 over here on this, but now I have to multiply this by some number to try to get the same number as on this side. So 2 times 5 is equal to 10, so 5 goes here. All right, so balance that one. And down at the bottom, we've got a couple of formulas to write out. This one's fairly easy. Hydrogen. Now, hydrogen is one of the 7 elements that's a diatomic. The diatomics are always listed as 2s. Incidentally, oxygen is always that way too. So when these elements are by themselves, hydrogen and oxygen, make sure you give them the little subscript of 2. On this side I have water, which is H2O. So now that's the correct formula, but then it remains to be balanced. So on this side I have 2 hydrogens and I have 2 oxygens. On this side, I have 2 hydrogens, and I have 1 oxygen. Okay, so I need to double the amount of oxygen on this side, make it 2, see, to make it the same, by doubling this, and that actually doubles the amount of hydrogen. It's up to 4. So now I have 2 here and 4. I'm going to double the amount of hydrogen here, and so there's the answer, is 2, 1, 2. And finally, I've got this last chemical reaction at the bottom of the page. This is another combustion reaction. Methyl alcohol reacts with water to form carbon dioxide and reacts with oxygen to form carbon dioxide and water. Okay, so let's lay it out. CH4O, so 1 carbon, 4 hydrogens, and 1 oxygen in the formula. And again, oxygen is O2. Carbon dioxide, that's 1 to memorize, and water, that's 1 to memorize also. So I have 1 carbon, 4 hydrogens, and 2 oxygens. So on this side I have 1 carbon, I have 2 hydrogens, and 3 oxygens. 2 plus 1 is 3. All right, starting always with the carbon first, then going to the hydrogen. The carbons are okay. Hydrogens, I need to double the hydrogens on this side to make it up to 4, so I'll double the hydrogens. And that actually raised the number of oxygens on this side to 4, 2, and 2. All right, so now oh wait, hold on a second. On this side I didn't have 2 oxygens, I had 3. I'm so sorry to mix you up on that. See, I have 1, 2, 3. So actually I have 3 oxygens on this side. I didn't notice that till just now. Well, that makes a problem because with 3 oxygens on this side and 4 on this side, there's no number I can put here that will correct this discrepancy. So what I need to do is exercise a little trick where I will double all of the coefficients that I've already got up there. So see, 1, 1, 2 becomes 2, 2, 4. Now that's going to help it because notice what that did. It doubles the carbons, it doubles the hydrogens. It doubles the carbons, it doubles the hydrogens. But what it does to the oxygen, now we have 2 oxygens and 2. It's up to 4 on this side. And here I have 4 oxygens and 4. I'm up to 8 on this side. 4 and 4 is 8. So I can correct this by adding more oxygen here. It turns out if I put a 3 here, I have 6 oxygens plus 2 is 8. And now they're the same. So that's the answer, 2, 3, 2, 4. All right, this is the podcast for the counting and balancing chemical equations. Thank you very much.